Okay, so goal for today, we're looking at the graphs of tan, secant, cosecant, and cotan. Yeah, so those four other functions that all depend on sine and cosine. So first, I'm going to zoom out here. We're going to do a quick review. So how do I find tangent from sine and cosine? Tan is equal to what? Sine over cos. Very good. This is sine over cos. Very good. What about secant? It's another fraction. I'll give you a hint. There's a 1 on the top. The question is, does sine go on the bottom or cosine? Cosine. Very good. This is 1 over cos, which means cosecant is probably the other guy. Cosecant is 1 over sine. And then what is cotangent? Cosine over sine. Good. It's the opposite of, or the inverse of tangent. And I'm going to scoot this up just a little bit. Looking at those shapes, I see a similarity between tangent and cotangent. Those look like they're very strongly related because they're a ratio of two functions. Thank you. And I see a fairly strong relationship this way between secant and cosecant, which involve only one trig function. So let's start with tangent, and we're going to go over the details of each one at a time. So starting in that first box. So we can see tangent. He looks a little weird. The first thing I see is I see a whole bunch of those dotted vertical lines where the graph doesn't exist. What are those called? Asymptotes. One of my favorite math words. It's fun to say, asymptotes. So why are we getting asymptotes? We're getting asymptotes because tangent is a fraction. And what are we not allowed to divide by in fractions? 0. Yeah, so all of those asymptotes are occurring where cosine, the bottom of that fraction, is 0. Because I'm not allowed to divide by 0. So that's where I'm going to get problems in my graph. But there's some patterns here. So let's just go down this list and check off stuff. So domain are the numbers I'm allowed to input. Those are the x values. Am I allowed to use all x values? I see one nodding. Are there places on that graph where there aren't a point on the x-axis? And I see yes, because I see asymptote. There's no curve there. Asymptote, there's no curve there. This domain, we need to tell where we're excluding, because it's not all reals. It's all reals except where those asymptotes are. So all reals such that x is not equal to whatever those asymptotes are. So let's look for patterns in where those asymptotes are showing up. So first asymptote I see is plus pi over 2. The other asymptote they show is negative pi over 2. How far apart are those asymptotes? Half a pi gives me a whole pi. Yeah, the asymptotes are pi apart, which means my next asymptote, this guy right here, is pi plus pi over 2, because I know the gaps between my asymptote are pi. So my asymptote is going to be everywhere where x is equal to pi over 2 plus some multiple of pi. 1 pi, 2 pi, minus 3 pi. Meaning those are the values that I have to exclude in my domain. You'll notice this is kind of the opposite of what we saw with sine and cos. Sine and cos took all inputs, but only spit out outputs in a specific range. The range was limited. These guys are the opposite. Their output is all real numbers. Their input is limited. I can't have values at pi over 2 or 3 pi over 2 or 5 pi over 2. So the range is nice and easy. I can see it goes to negative infinity on the bottom, positive infinity on the top. So this guy is minus infinity to plus infinity. That one's not so scary. I don't know why my infinities are crooked today. I'm sorry. And then we're going to go to intercepts. So we'll start with the x-intercept. So where is the graph crossing the x-axis? What intercepts are shown in the picture? I see 3. 1, 2, 3. Where are they occurring? I see you were about to mumble something into your hand, Arturo. What are you thinking? Negative pi 0 and pi. If I keep moving to the right, where do I think my next 0 is going to be? 2 pi, 3 pi, 4 pi. These are just multiples of pi. The asymptotes are then half a pi offset from the zeros, meaning I have an asymptote, and then half a pi I get a 0, and then another half a pi I get the other asymptote. So asymptote 0, asymptote. Asymptotes occur at the halves, zeros occur at the wholes. Good. Y-intercept, where does it cross the y-axis? Yeah, just once. It crosses at 0. Yeah, that one's easy. And then 2 familiar words. We talked about amplitude for sine and cosine. When I looked at my sine and cosine graph, what was amplitude measuring? Good guess. No. The height. Yeah, it was measuring how tall that peak was. Do I have really tall waves or really short waves? Is it a good day to surf or is it kind of lame day to surf? Yeah. Does that look like it has a peak where it stops and turns around? No, that doesn't look like a wave at all. This guy does not have an amplitude. Matter of fact, none of the curves today are going to have an amplitude. Okay, other word, period. When we looked at sine and cosine, what was period measuring? Yeah, the length or the distance between peaks, or how long it took me on the x-axis to get to the same y value. How often does my shape repeat? For this curve, if I pick my point 0, when is the next time I'm going to hit 0? Where's that second 0? Pi, yeah. This guy repeats every pi. That is the worst pi I've ever drawn. I'm sorry. This guy repeats twice as often as our sine and cosine do, because sine and cosine need 2 pi. 1 pi gives you the hill, the second pi gives you the valley. I need the full pi to get the whole cycle. Here, the whole cycle is contained in between asymptotes that are pi apart. And so a full cycle is contained within 1 pi. Okay. Ready for the next one? Yeah. All right, next one is secant, which is 1 over cos. What shape does it look like we're getting in those graphs? Yeah, they kind of look like quadratics. They look like U's. I have cups, I have hills, yeah, valleys and hills. That dotted orange line on my graph, it's probably dotted gray on yours, is cosine. What do we notice about the vertex of those U shapes? Where are they sitting relative to cosine? Very good. It's sitting at the peaks and valleys, or mins and max of cosine. So a lot of what we're going to describe about secant is related to the mins and maxes of cosine. Very good. Okay, so next process, we need to describe the domain. I see asymptotes. Frowny face. You may. So we make our statement all x so that x is not equal to, and then we're going to look for our asymptotes because those are where my graphs don't exist. So looking at those asymptotes, I'm going to go back and we're going to compare them to tangent. What do we notice about the asymptotes for tangent and the asymptotes for cosine or secant? The same. Yeah. This is occurring at pi over 2. The next one's 3 pi over 2. This one is doing the same, pi over 2, 3 pi over 2. Yeah, so this is going to have the same exclusions that tangent did. This is going to be, oops, if I can write, pi over 2 plus k pi. Yeah, which means those are the values I can't have over here. So tan and secant have the same asymptotes because they have the same function in the denominator. Tan's denominator is cos, secant's denominator is cos. So we're going to get problems in the same spots. Yeah, good. What about the range? That's our output. Do we get all values here? Do we see y equals 0 anywhere on that graph? No, no. The bottoms and tops of those u's are limited by where the peaks and valleys of sine were. Where are the peaks and valleys of sine normally sitting? Up and down, up and down. What's it oscillating between for the unit circle? 1. Yeah, it's oscillating between plus and minus 1. So this down here, this is at -1. This peak up here I can see is sitting at +1. It never crosses to get in between those two values. So my range has 2 chunks. I have the negative side from -infinity to -1. And that's a square bracket on the -1 because that point right here touches the cosine curve. It exists right there. And then I'm going to join that with the upper half of the graph, which starts at, very good, starts at +1 and goes upward forever. Yeah, good, good. Next fun question. Looking at that graph and looking just at the U shapes, because the U shapes are what form the secant graph, do you see any x-intercepts? No. Yeah, this guy never gets to y equals 0. So he has no x-intercepts. None. Yay. What about y-intercepts? Does the guy cross the y-axis? Yeah. And he crosses at cosine's peak, so his y-intercept is 1. Okay. Next one's easy, because I told you already, none of these have amplitude, because there's no wave shapes. Yeah. Period asks, how often does it repeat? Meaning, how often do I end up in the same spot? How often do I complete a full cycle? This guy has an upward U and a downward U. I have to include both. It has to make both the up and the down for a full cycle. So how long does it take me to get from the start of a cycle to the end of a cycle? So what was that you were mumbling? 2 pi. I think so too, because we know from tangent that those asymptotes are pi apart, and it's 2 asymptotes to complete a full circle. So I agree. I think our period is 2 pi, just like cosine's period is 2 pi. Thanks. All right, halfway done. Ready for the next 2? Yeah. Next one is the one we said was kind of related to secant, and that's our cosecant, which is 1 over sine. That shape looks awfully familiar, but now those peaks and valleys are occurring where sine's peaks and valleys occur, which are not the same as where cosines occur. Sine and cosine are shifted. So we're going to have to think carefully about where our zeros and our asymptotes are, yeah? So we'll start with domain. And domain, just like the other two, we're excluding where the asymptotes are. So this is an x not equal to, and it's going to be not equal to what my asymptotes are equal to. So looking at that graph, where are those asymptotes occurring? Oh. Do we see a pattern? Arturo is nodding his head yes. What do you see, Arturo? Good. Very good. Multiples of pi. Pi, pi over 2, negative pi, negative 2 pi, negative 3 pi, negative 4 pi. 0 is also an asymptote, which is 0 pi. Yeah, so these are just occurring at whole number multiples of pi. Just like sine is shifted from cosine by half a pi, its asymptotes are shifted by half a pi. The cosine asymptotes are occurring at a half, 1.5, 2.5, 3.5. These are occurring at 0, 1, 2, 3. So just like sine and cosine are related, secant and cosecant are related. Same shape, just shifted. Very good. What about the range of this guy? Range is output. What do we see? You can see Jaylee wants to say something. What are you thinking, Jaylee? Yeah, I agree. Same as the last one. Same as secant, because I can see that those bottoms and tops are occurring at the peaks and valleys of sine, which occur at 1 and -1. Yeah, so we get 2 chunks for our range. We get the lower chunk, minus infinity to -1, and the upper chunk, 1 to positive infinity. Yeah, I agree. Yeah. All right, next one is x-intercepts. Does this guy have any? No. Just like his cousin secant, he has no x-intercepts. Does this graph have a y-intercept? You see several people shaking their head no. Yeah, the y-intercept is an asymptote, meaning he's never going to touch it. So none for that. We know amplitude is also none because these aren't wave shapes. And the last question is, how often does it repeat? How long does it take to complete a full cycle of up and down? And we kind of already have a clue because we know this is similar to secant. What was the period for secant? 2 pi. Yeah, this guy is also 2 pi. The up cycle takes a pi, the down cycle takes a pi. I need the full 2 to complete an up and a down. Yeah. Good. Yay. Last one. You ready? Yeah. Okay, last one. Last one is cotangent. That looks familiar. It kind of looks like tangent, but if I zoom out, there's actually 2 differences here. So first, tan is increasing. It's always going from bottom to top. Cotangent is increasing or decreasing? Decreasing. Starts high, goes low. Good. And then the other thing we need to look at are where are those asymptotes occurring? So we know for tangent, they were occurring at the halves. Pi over 2, 1.5 pi over 2, 2.5 pi over 2. Where are these asymptotes occurring for cotangent? What's halfway between pi over 2 and 1.5 pi over 2? What's halfway between those two? 1. Should be 1. This is occurring at 1 pi. Yeah. This is occurring at pi. This is occurring at 2 pi. This is occurring at 0. That's an asymptote. This is occurring at minus pi, minus 2 pi. So this guy has nice asymptotes just like cosecant does. The domain is all x such that x is not equal to k pi. The asymptotes are at k pi. Yeah. All right, next one. Range, that's the up and down, the y values. What's our range for this graph? I see an arrow going down, arrow going up. What does that tell me? Infinity to infinity. Yeah. This guy covers the whole y-axis, minus infinity to positive infinity. Yeah. Good. And if my range goes all the way from negative to positive, at some point between those, it has to cross the x-axis. So where are those intercepts occurring? Where are those zeros happening? What do we notice about those zeros? They're pi apart. What else? They're occurring at the half pi marks. Pi over 2, 3 pi over 2, 5 pi over 2. Yeah. So these x-intercepts are the asymptotes for the first 2 graphs. These are occurring at pi over 2 plus k pi. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Yeah. Good. Good. Y-intercept. None. Yeah, this guy doesn't have one. We know he doesn't have an amplitude. He's not a wave. And then how often does he repeat? Pi or 2 pi? That's the question. Pi or 2 pi? How often does he repeat? How far apart are his zeros? Pi, yeah. Just like his friend tangent, he's repeating every pi. Okay. Deep breath. Yeah. On the next page, I want you to take a couple minutes and I want you to identify your noticing about the graphs of tangent and cotangent for that first question, and then the graphs of secant and cosecant. How are they similar? How are they different? Yeah, I'm going to put a couple minutes on the clock. Person facing the board and the chair facing the board, you are the discussion leader. How are those graphs similar and different? When do we get out? Because I don't remember now. 10:05. Oh, we got time. We got plenty of time. I'm going to call on each group to share, so make sure you've talked to each other. And come back together. It's okay. And talk about what we see similarities and differences between those two graphs. We're going to start with tan and cotangent. Andres, what did your team come up with for tan and cotangent? Give me one thing. So similar, range, amplitude, period. Good. Diana, what did your table come up with for tan and cotangent? Yeah, good. So tan is increasing, cotan is decreasing, yeah. Very good. Kira, does your table have anything to add? What do we see? The asymptotes and x-intercepts are flipped? Yeah, good. Very good. One has asymptotes where the other has x-intercepts, and vice versa. Very good. Cynthia, what did your table come up with? Anything to add? Not for that one. What'd you get for the next one? Yeah. So secant has an x-intercept, cosecant does not. Yeah. Very good. Next table, LG, what'd your table get for either one of those? So same period, if I knew how to spell, period and range. Very good. Y-intercept. Y-intercept. That makes a little bit more sense because I don't think either has an x-intercept. Good catch. All right, Tony, what about your table? Either one, what'd you get? Give me something.
I was gonna say for secant and cosecant, neither have an amplitude nor
Yeah. Good. Abner, what about your table? Anything that's not up there? Ooh, so both of these have a U shape. Yeah, good. I know we use quadratic because that's how we recognize U. If you look closely at those graphs, these are a lot steeper than those parabolas. So they grow a little bit different. The bottom of their U's are flatter and the sides of the U are steeper for this guy. Good. Very good. We're going to pick up where we left off tomorrow. Remember, after lunch, go to fifth. After lunch, go to fifth. After lunch, go to fifth.